In this video, we take a closer look at how the Taleo Adapt uses its hydraulics during the gait cycle, for both level ground walking and when walking on inclines and declines. Observe the behavior of the foot and knee and pay special attention to the angle indicator lines on the hydraulic unit during the individual phases of gait. In this example, the valves are optimally set for the user. From a full dorsiflexed position at initial contact, the ankle is smoothly plantar flexing during loading response until reaching foot flat. From that plantar flexed position, the ankle dorsiflexes throughout mid-stance as it passes through the neutral position during rollover and finally comes smoothly to the dorsiflexion stop at terminal stance. The dorsiflexed position is kept during swing phase. Minimum plantar flexion resistance will lead to a very quick foot flat and increased plantar flexion during loading response. In mid-stance, the ankle has not yet reached the neutral position again. By comparison, maximum plantar flexion resistance will lead to a stiffer heel behavior and a greater propulsive effect. The plantar flexion motion into loading response will be limited. The dorsiflexion stop is already reached during mid-stance. Minimum dorsiflexion resistance will lead to a quick transition into the dorsiflexion stop after mid-stance that can be felt by the user. By comparison, maximum dorsiflexion resistance results in a feeling of walking uphill. The dorsiflexion stop will be reached too late or perhaps not at all. The fully dorsiflexed position at initial contact supports uphill walking. Depending on the inclination of the ramp, the plantar flexion motion during loading response is either reduced or perhaps not present at all. From initial contact to loading response, the increased plantar flexion motion can be observed depending on the inclination of the ramp. Compared to level ground walking, the dorsiflexion stop will be reached later or perhaps not at all.